Good morning students, this is Abhijit sir. For this video we have the topic formation of image by a lens. This is from the chapter 5b of class 10 physics, and then later we will also discuss about the chapter 5c, that is the sign convention and lens formula. Let's start. We have an object. Here this up-headed arrow AB represent an object. See, the object is consist of infinite number of points, but we are considering only the 3 point. A is the top point, B is the bottom point, and X is the point somewhere at the in the middle of the object. So as you know that the object have infinite number of points, and all the points act as a source of light, and all the points can send the light rays from them. Okay, so here like point A is acting as a source of light and sending the light rays in every direction. There are also the rays going out from this A toward this. Okay, that means the point A sends the light ray toward the left also, but here we are considering only some of the rays which are going toward a lens that kept in front of the object. Okay, so the X also, the point X and the point B also sends the rays. Okay, now see how the object is placed. And the object is placed, see, the object is placed in front, that is the left side of the lens. Okay, so the ray of light, these are the three principal rays that we are considering about, because each point sends the rays in infinite number of rays. So we are to be considered only the three principal rays. See, one point sending in many rays from it. Okay, and we are considering here the principal rays, that means only the three rays. There are three principal rays. So see, first, the first principal ray is the ray of light from any point of the object that incident at the optical center O and passed undeviated through the lens. This is the first principal ray. We have the figure. Okay, now second, we have the second principal ray, a ray from the object incident parallel to the principal axis. It is parallel to the principal axis and refracted to the second focus of the lens of convex lens. And for concave lens, it is refracted away, that means it is diverged away from the lens in a direction such that it is appearing from the second focus of the concave lens. So let's see, we have a figure. See, this one is the first principal ray. You can this is the third principal ray. See this one first, the ray of light incident from the first focal point of a convex lens or directed to the first focal point of a concave lens and emerges parallel to the principal axis. So first, see, the first principal ray is passes through the origin, passes undeviated. Okay, the second principal ray is incident parallelly on the lens, and it is then emerges out along the direction of the second focal point, okay, of the lens. Now the third one is, see, we have the third one. Okay, see this one first. See, this is the third lens. In the third lens, we have the light ray which is passing from the first focal point, and then incident on the lens, and then when it is emerges, it is parallel. See, this one is I'm saying about. Okay, a ray of light incident from the first focal point of the convex lens. So this is the first focal point, and in the case of concave lens, it is directed to the first focal point. Let's see, we have the concave lens also. See here, this one is passes from the first one. You can see it is the ray passes from origin. The second one, the ray is incident parallelly in the second figure. Okay, in the lens in the middle, the ray incident parallelly, and it is diverges away from the lens. It is emerges away from the lens in a direction that it is appearing, that in a direction that it is appearing from the second focal point F2. Here it is mentioned here. Okay, so the direction of the emerges ray in the second figure, you can see it is in a direction such that it is appearing from F2. Now here in the third figure, in the last figure, you can see the light ray incident in the lens in such a way that it is directed to the first focal point F1, but now in the presence of lens there is a refraction and the ray will emerge parallel to the principal axis. So these are the three principal rays I am talking about. Now see the next page. Here the light ray from the top and bottom point of the object are taken to incident on the lens. We also can consider the third ray also. That means the third principal ray we can consider. But if we take the first two principal rays, then we have the image. See, the formation of image we are studying about, and for that we need only the two principal rays. Third is not necessary, but we can mention the third one also. But here we have only the two principal rays. See, the light ray sending from the point A of the object, the top point, and it is also sent, see, it is also sent, um, see here, this is the second one, this one is the second principal ray, it is mentioned here, you can see easily. Okay, 2 point is given, that means this one is second principal ray and this one is the first principal ray, you also can see. Okay, so light ray is sent by the point A and also from the point B. Okay, sorry, see this one, from point B, which is at the bottom, the light ray is sent toward the origin and it is passed undeviated. Okay, if you want, see, from the point B, there is only one ray that is passes from the origin and which is along the principal axis. Now see, when those rays are passing from the lens, see, there is a refraction and the ray is converges toward the point F2. Okay na, and the first principal ray passes through the origin without deviation. Okay, so the rays, that means the emergent rays, the rays after reflection from the lens, where they will meet at a point. See this once again, here they are meeting here at this point. Okay na, here at this point they are meeting. So this point, see this clearly, this point is the image of the point, the point which sending the light rays. Okay, here the point A is sending the light rays. Okay, see, the point A is sending the light rays we are considering about. So where those two light rays will meet after reflection through the lens, it will be the image of the point A. In this way, if we draw the rays from X, we will have the image X dash. For the point X, we have the image X dash. Then in this way, if there is any point on the object, we have all the images of those points, because all those points of the object, because this object AB consists of infinite number of points, and all those points sending the light rays and have their images here. Okay, so in this way, by combining all those image points, we have the image of the object, and this is the real image. Now see why it is real image. See this one, here it is mentioned that it is real image. Okay, here you can see this is real image. Okay, now why it is real image? Because this object, this image of the object, this a dash b dash, a dash b dash, you can only obtain if there is a screen here. Okay, that means if there is a screen placed here, then on the screen you will have the image, that is a dash b dash. Now you can see here, initially the object is upright. Okay, as a is the top. Okay, but here we have the inverted image. Okay, inverted image means you all know. So the real images are always inverted. Okay, and see, the real image also we can obtain in a screen. The real image can be obtained on a screen, those are always inverted. Okay, and here for this lens we have the real image always, but there is one condition, we will study about those later in this video. So here one more point is there for the real image, that is the real image always formed to the right side of the lens. Okay, now see what about the uh, concave lens. See, this one is the concave lens, you all can see. Okay, clearly the figure is mentioned. So the light rays sent from the point A and B. Okay, so the point A send the light rays. See this one, it is diverges away from the lens in a direction, it is appearing from F, and that is the first principal ray is passes from origin. Now actually those two rays, see, I am talking about first this ray. See this ray, okay, which is emerges out from the lens, and this one ray which is passes from the origin and emerges out undeviatedly. Okay, so those two rays will never meet, because it is go in this direction, it is going in this direction. So we will produce this ray backward. Okay, and here we have the point, the common point, and it is appeared that both the rays which are passing like this, okay, which is going toward this, both the rays are appearing from a single common point, and that point is the image of the object a point which we are taken, that means which we are taken, that the point sending the light rays initially. So here A is sending light rays, so that means we have the object. For the point A we have the image A dash. So in this way we also get x dash. Here x dash is also mentioned here. See, the middle point x, we have the image of x. So in this way we got all the points as image, and here it is b dash. Okay, for B. Now this one is the virtual image. This one is the virtual image. Why it is virtual image? Because here the image is actually appears to be inside the lens. Okay, it is appears to be inside the lens like a plane mirror. Okay, but actually there is no any image. It is just a virtual image that we can see inside the lens. Okay, so it cannot be obtained on any screen, and it is always upright, erect as the object is. Okay, so this is the, and it is also one more sorry, it is always to the virtual image is always to the right left side of the lens, whatever lens it is, maybe it is concave or convex. See, now see some of the special case. What we found that in the case of concave lens, we always have the um, real images. Okay, so here see, this one is the image formed when the light rays coming from the infinite object. Okay, so infinite object, that means infinite size. So these are the light rays. When we are considering that light rays, we are considering that many rays parallel to the principal axis incident on the ray lens, and those are converges at a single point, that is called the focus, the second focus. So here at the second focus we have the image of the object which is placed at the infinity, which is at an infinite distance from the lens. Okay, so in this way we can draw the ray diagram for the rays that those are coming from infinite. Okay, infinity. Now the other objects, that means the at the different position of the object we are already consider. You also can draw the ray diagrams by putting the object in different places. Okay, for this, see this figure. Okay, in this figure, see, we have, this one is optical center, this one is first focus point. Okay, and this one is 2f mentioned here na. So 2f means, see, this 2f means actually the distance from the focal optical center to f1 is small f. Okay, that means focal length. So if we consider the length from this to this, so this is 2f2. Okay, as because this one is a biconvex lens, so here we have f1 equal to f2. Matlab, I mean both the focal lengths are equal, so f1 or f2 both are equal, we can take as f. So the length, the distance is from here to here, it is f, that is the focal length, and from here to here this one is 2f. Okay, 2f. This place is also, this place 2f, this point 2f is also the center, is also the center of, it is actually the center of curvature. Remember center of curvature while we are studying about the formation of lens.